Hello everyone, I am Roshan Kumar and in this present study we will see effects of the climate change on air pollution of Indian subcontinent with particular attention on Indian regions. Every day we hear news about air pollution and on phone Google never forget to show our local air pollutant concentration. Also, global warming and climate change is yet another hot topic with front lines and breaking news on every other week. So, we can all predict what a research paper like this on this topic contain without even going through it. But in this paper, there is twist, and what are those twists? We will see later. For first, let us remind us why we need to worry about these tiny little stuff PM 2.5 and why these really and what these really are. So PM 2.5 are fine inhalable particles with diameters that are generally 2.5 micrometers and smaller. These tiny little things have their sources at construction sites, unpaved roads, fields, factories, exhausts, etc. And they are really bad guys. Why? Because their long term exposure has potential health impacts as they can get deep into lungs and some may even get into bloodstream causing disease like asthma, allergy problems and sometimes even cancer. Now India, the second most populous country in the world, is recognized as a hotspot of aerosol loading where ambient PM2.5 2.5 exposure by absorbed to increase rapidly over the past decade. So this tells us how much health burden these tiny particles can create on our economy. Also, besides health impact, in this picture, as we can see here, uh, the pollutant PM 2.5 cause reduced visibility in many cities, which further leads to accident and loss of life and property. So we found it interesting to know how this PM 2.5 concentration will vary with climate change in the coming decade. So moving on to the next slide. So what climate change do is that it modulates ambient PM 2.5 exposure by perturbing these parameters like ventilation rate, precipitation scavenging, dry deposition, anthropogenic and natural emission, and background concentration. On the other hand, some of the atmospheric pollutants, including PM 2.5 and aerosol, enhance the climate change because of many direct and indirect effects. These air pollutants have considerable impacts on the climate by hitting lower and mid troposphere, causing sea land temperature gradients, monsoon circulations, distribution of rainfall, solar dimming, cloud microphysics, etc., and thereby modify the heat wave frequency, intensity of storms, and precipitation pattern. For increased concentration of air pollutant have an impact on global climate change. Therefore, it is important to understand the relation and equally important to know how the current ambient PM 2.5 concentration is projected to change in the future over the warming climate. So for that, we try to project the ambient PM 2.5 concentration in India by analyzing 13 coupled model intercomparison project 5 CMIP5 model data for the two climate change scenario represented by the RCP 4.5 and the RCP 8.5. Then we use these two approaches to get our results. But before that, let us quickly see what is RCP 4.5 and RCP 8.5 are. Now, RCP stands for the Representative Concentration Pathway. These were used in the fifth assessment report of the IPCC in the 2014 as a basis for the report's finding. Here, RCP 4.5 is a stabilization scenario where total radiative forcing is stabilized before 2100 at 4.5 watt per meter square without ever exceeding that value. That means 650 ppm CO2 equivalent by employing a range of the technology and strategies for greenhouse gas emissions. And the RCP 8.5 scenario corresponds to the pathway with the highest greenhouse gas emission, leading to a radiative forcing of 8.5 watt per meter square. That means 13 170 ppm CO2 equivalent by the end of the century. Here we use these two only because we feel that RCP 2.56 scenario is difficult to achieve, and the RCP 6 scenario lies between RCP 4.5 and the RCP 8.5. Therefore, RCP 4.5 and the RCP 8.5 are expected to provide a realistic range of the estimates in the future. Now, coming back to the approaches, uh, here in the approach 1, PM2.5 is estimated as sum of the mass of the individual species, as we can see from each of the 13 CMIP5 model. After that, we follow a study in estimating the results. We assume the fraction of these species to remain uniform through Indian landmass in the absence of the information about spatial heterogeneity. And in the approach 2, we used AOD simulated by each of the 13 CMI5 models and converted it into the surface PM2.5 using a conversion factor eta. So for the difference in the estimated PM2.5 by these two approaches can isolate the role of the meteorology in warming climate in modulating PM2.5 distribution. Now what we get by this method is that ambient PM2.5 exposure estimated using approach 1 and the averaged over the Indian landmass is estimated to 34.5 microgram per meter cube for the baseline period. Here we can see projected PM2.5 exposure over India up to 2100 under both the RCP 4.5 and the RCP 8.5 scenarios. This shaded part represent the range in all India averaged PM2.5 across the 13 CM IP5 models, and the black line represent the all India averaged baseline PM2.5 exposure level. We can see the projected exposure using approach 1 and approach 2 by these solid and the dashed lines. Here it's clear that PM2.5 exposure lowers below the baseline period exposure only after 2090 under the RCP 8.5 scenario, and under the RCP 4.5 scenario, PM2.5 exposure falls below the baseline period exposure after 2050. Now for getting the spatial distribution, we can move on to the next illustration, and here we can see how projected change in the PM2.5 vary over the regions from the baseline period, that means 2001 to 2005 under the RCP 4.5 and the RCP 8.5 for the near future, that means 2031 to 2040, and for the distant future that means 2061 to 2020, and for the far future that means from 2091 to 2000. The regions with more reddish tinges here show increase in the PM2.5 in the future, and the more the bluish tinges, we can see more decrease in the PM2.5 concentration in that part. So these outcomes give us a fair enough idea of variation in the PM2.5 in the future. Now we can conclude from this that though most likely in the coming decade we have to face increasing PM2.5 concentration, but by the end of this century the concentration will decrease, and so does its impact on the health and the economy. But for the coming decades also, if necessary planned steps are taken by the government, then we can see mitigation of the air pollution in future decades, at least with respect to the PM2.5. However, further study has to be done on the combined effects of the air pollutants to get a better idea, and we hope to get such research work soon in the future. And with that, I would like to thank all and end the discussion. Thanks a lot.